Hi, this is Mrs. Pope from Roger Bacon High School, and today we're going to be talking about multiplying polynomials by monomials. So in class, we went over the terms monomial, polynomial, trinomial, binomial, all of those nomials, and now we're actually going to be doing more things with those. The first part of your notes here, you'll notice actually just a little bit of review from our class with your vocabulary here, talking about a monomial, polynomial, and just some graphics for you. And we already talked about this. This means that a monomial is a single term, so there are no plus or minus signs. Again, this is just review, but it's good for you to have to reference. And there are a couple examples for you of a monomial, binomial, and trinomial. So just keep that as a reference, and we'll move right on down to the practice. So yesterday in class, or whatever day you're watching this, the last time when we did sections 9.1 and 9.2, we were adding and subtracting. Well, now we're moving on to multiplying. But before we can multiply these, there is one thing that you do need to know. And before that, there's a rule that we have here that you need to know. And that rule is the product of powers. So we have a rule here, and you may have used it last year, but if you have two numbers that have the same base, or two variables that have the same base, so x to the power of a times x to the power of b. If you're multiplying the same base, so they're both x's, then what we do when we're multiplying is we actually add those exponents. So we keep the base the same and add the exponents. Now that's in formal terms. Let's give it some numbers and some real examples. So here's one example for that. If you had x cubed times x to the fourth, that's going to end up being x to the seventh. Example 2, if you have 3x squared times 2x to the fourth, what's that equal? Well, my coefficients I need to multiply as I would normally multiply numbers, so 3 times 2 is going to be 6, and then I have same base, different exponents, I can add them. So I end up with 6x to the 6th power. Two more examples. Remember, you can follow along with me, or you can pause if you need it, if it's going too fast. Do whatever you like. Example 3. 5x to the fourth, put that in parentheses, times negative 2x. Try it out. You should have gotten negative 10 because I'm multiplying the 5 times the negative 2, and then x to the power of 5. That will be my final answer. So this is my final answer, final answer, final answer. Let's just do one more. If you have 4x times 2x, what's it going to be? What do we think? 8x squared. All right, let's move on and try some actual multiplying. That's just the rule that we needed to know. So now that we're going to multiply, the way your problems are going to look, you're going to see something like 4x times 2x minus 3. And I promise we will get to real world examples of this. We'll start finding areas of different things, finding areas of the shaded region. We will get to that, but I want to make sure we know the basis before we start moving on. So here, I know we're all familiar with the distributive property, where we would take the 4x times the 2x, and we're going to take the 4x times minus 3. So 4x times 2x, as we learned up above, that's going to leave me with 8x, not plain x, 8x squared, minus 4x times 3, 12x. And this here, folks, would be the final answer. Not too bad, huh? Let's move on. Example 2. Negative 3x times x minus 5. Okay, we need to use the distributive property. Take negative 3x times the x, negative 3 times the minus 5, and we're end up with negative 3x squared plus 15x. Again, if it's going too fast, pause it. 5x times 8x cubed plus 7x squared minus 3x. Now we have a monomial multiplied by a trinomial. Same thing happens. If you'd like to try to beat me, then race me, see if you can get done before I do. You probably will. Multiply every single term by the term on the outside. So 8 times 5, I'm going to end up with 40. X to the fourth, and then 5x times 7x squared, end up with 35 x cubed, and 5x minus 5x times 3x, we end up with minus 15x squared. All right, what do you think? Hopefully you got the same answer as I did. Two more examples. 5d times d squared plus 3. Go ahead and multiply that out. It's 5d cubed plus 15d. And that will be our final answer. These go pretty quick. Last example for us. Negative 5x squared times 3x squared minus 8x minus 12. And it's a trinomial, so we need to go make sure you multiply by all three terms. So I'll end up with negative 15x to the fourth plus, because negative 5 times 8, plus 40x cubed plus 60x squared. If you didn't get that, or you got something different, or any of these notes anytime, write down any questions that you may have so that I can answer them when you get back in class. Now your turn. These are the problems I want you to complete, and this is what I will be checking along with your completed notes. On page 396, you want to do numbers 4 through 12 all. All right, happy multiplying. See you next time.